So the first part, we're trying to find the speed at the instant her parachute opens. So we're trying to find the velocity v after time, or after t is 3. We know the acceleration is 10. So then we're doing v equals u. We know u is 0 because she starts at rest. So v is 80. So after 3 seconds, velocity is 30 seconds. We're then going to sketch a speed time graph. So we know in the first 3 seconds, it's got the acceleration due to gravity. So constant acceleration of 10. So we know it's a straight line. Straight up, that happens for 3 seconds. And it goes until the velocity is 30 meters per second. We've then got the second phase, which is the deceleration, i.e. after the parachute opens, there's a deceleration of 12 meters per second. So for this phase, it starts at 30 meters per second, is a deceleration, so it's negative 12 for 2 seconds, and then we want to know what the velocity is at the end of that time. So again, we're going to use v equals u plus at, which is 30 minus 2 times, or minus 12 times 2, so 30 minus 24. So after 2 seconds, she then has a velocity of 6 meters per second. It's a constant deceleration, so it's a straight line. We know that the time will be 5, because it's 3 plus another 2 seconds. The speed is at 6 meters per second. We then have so reaching a constant speed, and she reaches the ground. A constant speed is a horizontal line, and we know it goes till time is t. And what do we know? We know that the area under a speed time graph is equal to the distance covered. So we know that the total area under this must be 550. So we can break it down into the bits we know. So area A, half base times height. So that area of that's 45. Half times 3 times 30. Then we can do this section here. Obviously you can split this up in slightly different ways, but the fewer regular shapes we can do it in, the better. So the base of this shape is 2, the height is 24. So half times 2 times 24, which gives us 24 meters. And then we've got this section here, which has a height of 6, because that's the constant speed, and it has a length of t seconds minus 3, because that length there is, the whole length is t, but we're starting at 3. So the area of C, is 6 times t minus 3. And we know that all the areas added together must give us 550. So C is 550 minus 45 plus 24, which is 69. So the area of C, the area of C is 481. So then we have to solve our equation for C to find the unknown, which is T. And we're working out to the nearest whole number. So T is 83 to the nearest seconds. Nearest second. In a refinement of the model, we include air resistance. So what happens? Well, basically that means that all downwards motion is going to be slowed down. So initial acceleration would be less than 10. because the air resistance would slow it down. The deceleration would be more dramatic. The constant speed would be slower. Okay, so the overall time taken to reach the ground would be longer because all speeds of descent would be lower. Further refinement, there are a few here. We could be more accurate with the value of G, use 9.8. We could allow for the dimensions of the parachutist rather than just considering them to be a particle. We could allow for the effects of wind. We could not assume that it falls perfectly vertically, okay, allowing for the effects of spin of the parachutist. Those are the ones included in the mark scheme.